This is a question on the magnetic field of a coil or solenoid, and also we must use our right hand grip rule to determine the polarity of the solenoid electromagnets. So we can first trace the direction of conventional current to determine how does current coil around the wires or around the solenoid, and I put in the blue arrows to show this direction. Now, applying our right hand grip rule by letting our curvature of our fingers represent the how current will flow in the solenoid, we realize that our right thumb is actually pointing towards the right side of the screen. So this means that on the right side of the solenoid, that will be the north pole of the solenoid, and on the left side of the solenoid it will be the south pole. So this is how we apply right hand grip rule. Please approach me if you need help to apply your right hand grip rule on this kind of scenarios. Now, because the two metal rods are placed within the solenoid, they will be magnetized the same way as how the magnet or how the solenoid is being magnetized to become an electromagnet. So with the two north poles of the two metal rods on the same side and the two south poles of the metal rods on also the same side on the left side, we will see a repulsion. Therefore, this repulsion between light poles is the reason why the two metal bars will be pushed apart from each other. For this part, what happens if now we use an alternating current, which is a current that swaps direction very frequently, many times a second. So we can draw two diagrams, one to show the first one to show this particular direction of current, and this is like what we have analyzed previously in part A. This will cause a repulsion after you use right hand grip rule to determine that the right side of the solenoid is a north pole. Now, what happens if the current changes direction? So that is where we put in the new direction of current in the second diagram, and again applying right hand grip rule, we will then determine that the left side of the solenoid now becomes the north pole. Now, if you look at these two diagrams, we notice that yes, the north part of the electromagnet and the north part of the iron rods has indeed changed position. Previously, it was on the right. When the current changes direction, the north pole now becomes on the left. However, both the iron rods all have the same north pole on the same side. This will mean that regardless of the direction of current, we should always see a repulsion between the two iron rods. And this is the reason why the two iron rods, in this case, it will still stay apart from each other because of the constant repulsion.